Hi, this is the first of two videos on including Desmos interactives in your class. In this video, I will talk about how you can build interactive graphs in Desmos, and in the next video, I will talk about turning graphs into activities and how you might include activities or graphs in Blackboard or any learning management system that supports iframes. All right, I want to show you how we can create nice interactive demonstrations with Desmos. You can create animations or interactives that people can kind of manipulate and tweak and move around and see how things change pretty quickly. One of the nice things about Desmos is that it's very powerful. It's got a lot going on kind of under the hood, but at the same time, it's very accessible. The interface is not intimidating at all, and kind of you try to do a natural thing and it works. So here I have a function f of x, and I want to think about how I might build a Riemann sum demonstration with this function, just using what Desmos allows us to do. So if I want to think about visualizing Riemann sums, I want to see those rectangles appear, right? So that's my first goal, is to kind of make some rectangles appear corresponding to some parameter n. So to begin with, maybe I'll think about my lower limit of integration and my upper limit of integration. I'll call those a and b, and then I'll add a parameter for n, which is the number of rectangles. And now that I have a, b, and n, of course, if I use equal width rectangles, which I'm going to do, then delta x, the width of each rectangle, would be just b minus a over n. I'm just going to use capital D for that because it is convenient. And now the next thing I'm going to think about is, well, when I do those rectangles there, I have to pick a sample point to get the height of those rectangles. You could probably get really sophisticated with this, but I'm going to go ahead and think right now about whether I want to do right endpoint rule or left endpoint rule. And I know in the formula that's either I subtract one when I do my calculation or I don't. So I'm going to introduce a parameter s and just call it -1, thinking about doing the left endpoint rule. And at this point, s really should only take two values, -1 and 0. So I can just modify those parameters right now so that it's ready to go. And you know what, I might as well go back up to n and do the same thing. And let's say we can go up to something like 40 rectangles, but I know it's going to be an integer, so I'll have n go, probably 0 doesn't make sense, so I'll have it go from 1 to 40. Okay, so my n is ready to go and my s is ready to go. And now if I think about how those rectangles appear, this is where we really take advantage of some of the hidden power of Desmos. How am I going to draw a whole bunch of rectangles conveniently? Well, Desmos supports something called lists, and lists are basically, you can kind of think about it as the equivalent of a loop. So I'm going to use a parameter I and use a square bracket, just 1 ... n, and you can already see Desmos recognizes that I want to build a 4-element list. So it really is supporting indexing variables or iterating over a list. When I do something with I, it's going to do it for each element of that list. So if I want to get my rectangles now, well, I've conveniently created this so that everything is above the x-axis in the interval from a to b that I'm interested in. So I'm going to go ahead and set y greater than or equal to 0 and less than or equal to f of a plus I plus s d. And of course, what you're seeing now is a whole lot of overlapping green stuff on there because I've created a bunch of shaded regions, and they're all these vertical bars that have this infinite width because I haven't restricted the domain of those functions. So I can just go ahead in here and just set that to be let's see, a plus I minus 1 d should be less than or equal to x should be less than or equal to a plus id. Oops, id. And there we go. There we see our rectangles appearing there. So we see the heights of those rectangles. If you want, you can get fancy and draw the vertical line segments for those rectangles. I'm not going to bother with that right now. But let's just see what happens as I animate that parameter n and let it range from 1 to 40. So you can see, if you'd like to slow this down maybe a bit, so because it's a little fast. So here we can see what it looks like as we have more and more rectangles going. So that's it. It only takes a few minutes once you know how to work with the tools to kind of build something as simple as a demonstration of what rectangles look like in a Riemann sum, and even animate that. And now if I want to switch from right endpoint rule to left endpoint rule, I can just tweak the value of s, right? And you can see we're swapping back and forth between right and left endpoint rule. And maybe, you know, how come I'm not actually viewing my parameter a and b, right? Maybe I want to label that. So I can add a point on my graph. And so we're going to do a, let's just put it right on the x-axis. We'll call it a0. And we'll do that in black. By long pressing, by holding the mouse down on this circle, you'll open up this little menu. I do want my point to be draggable, to be left and right. And I'm going to go ahead and label that point. And again, here we see some of the power of Desmos, where I can include a little bit of mathematics in my labels and actually reference variables. So if I do backtick a equals $a, close off my backtick. And Desmos is going to put that where it thinks you want it, but I know that I want these to be below, so I'm just going to set that there and maybe make it a little smaller. Okay, so there's my A. And now this point I made to be draggable, so as I drag it, the graph is responding. It's going to change. And same thing, I can add a parameter b0 and give that a label and also indicate the value of that b. Also make that small and have it be below. And now we can change our a and b values. And you'll notice, of course, what happens here is as I drag a over, I go below the x-axis. So I can fix that by coming back up to where I drew those rectangles. And instead of going from 0 to the value of the curve, what I really want to do is go from the minimum of the two to the maximum of the two. So minimum of 0 and f of a plus I plus sd, and the maximum of 0 and f of a plus id. And now we can see that's appearing nicely in that chart there. So you can handle, now if you wanted to, you could do two separate lines, one that does above and one that does below, and have the ones below in a different color, right? So maybe I didn't like this after all. Maybe I want, let me hide that because I don't want it to show. And I'm just going to copy all that and create a new line where I go from 0 to the function just like I did, delete all the maximum stuff, and you can, again, you can actually drag this out of it if you want to see more of that. Okay. And I want that to be in green. Green means positive somehow. And then I'm just going to copy all this and create a new line. Put this one in red, because red somehow denotes negative. And so I'll just, if the curve is below it, it'll capture that in red. Then of course, you know, if red is somehow denoting that, maybe I should make this a blue curve, which is somehow neutral. And so now as I drag that A and B back and forth, I'm getting different values. Maybe I'll even demonstrate it a little bit more by changing this to something like a 3, so part of it is below and part of it is above. Right? And so you can start to see how you can modify all these different parameters and change them. So I think that demonstrates a lot of the power. I think I will leave it at that. You can push this a fair amount further. So I'm going to jump over to the demonstration that I had previously created. So here's a different demonstration where I used a whole bunch of labeling to see what delta x and and the estimated area R and the actual area R. So I have formulas that actually calculate those and then display them. I created I wanted to do an example with a function that didn't have an elementary antiderivative. So I created this example, and then if you want to I added a second line here so that if you wanted to copy in and copy out. So this is the one that's always being worked with. But if I want to save this and type something else, I can copy this down to there. So it just gives me a space to save the function I want so I don't have to think about what it was later on. So here I'm drawing my rectangles. I did put in a little bit more effort to actually draw the horizontal lines on those rectangles, but I didn't go through the effort of making the negative ones red in this demonstration. But you'll notice what I'm doing here on the graph is I've set it up with those draggable points associated to the different parameters. You're actually changing those parameters, which means I can build right into my graph exactly where I want them to be able to be dragged. And so it kind of has this animated switch here. And same thing here, n, by just moving n back and forth. So you can start to see, even built into this graphing calculator is the ability to kind of have these manipulatives. And what you'll also see is it supports lots of organizational tools. As these things get more complicated, you have line after line after line. It gets much harder to keep track of what's happening. So Desmos supports adding notes, adding tables, adding folders, and even dropping in images if you want to. So fundamentally, it's built out of these mathematical expressions, but you can see here we have this note that kind of gives the user some information. Here's all of my math for drawing those rectangles. There's not too much of it. And then I kind of took all my draggable parameters and kind of squirreled them away into this one spot here. There's another feature to this which I haven't turned on yet, which is just if I want to be able to view heights, I can, let's see if I can, if I turn this on here and turn this on here, it's actually then, oh, I have to make it visible though. It's actually going to show me the heights. Oh, I have them way up here. I have this draggable doohickey that lets me. So if I want to see the heights of my rectangles, if I have a ton of rectangles, like, well, 13 apparently is a ton, it becomes really hard to see what those heights are, but maybe I only have 4 or 5 rectangles. I might really want to know what those numbers are. And so here I can just conveniently see what the heights of all my rectangles are. So that way, if I was actually doing a calculation by hand to check that the Riemann sum calculation really was working, here are my actual heights. I'm going to actually show you one more thing while I've got this open, because you'll see Desmos likes to display numbers to whatever precision it likes. That can be a little bit tedious. For example, you'll notice over here I just have this to 3 decimal points and delta x to 3 decimal points. Those might naturally be to 3 decimal points, I don't remember. But for my heights, what I'm going to do is just take those values and I'm going to round them to, well, let's say 3 decimal points. So I'm going to take that number, multiply it by 1,000, and then round that off to the integer and divide by 1,000. And now I have those heights nicely to 3 decimal points. It makes it a little bit less messy. But there is a lot going on here, so I have a note here for the user. By default, these are turned off. And you can just click those to turn them back on and make them visible again if you want to. So that's packed into that folder there. Here are my calculations for actually building up my Riemann sum. Again, I do have my Riemann sum and the value of the integral rounded off to 3 decimal points. But you'll see that Desmos supports nice summation notation, so I didn't have to go through a lot of effort with that. I am using a different variable k because I already have I for very special purposes in building my visualization. I wanted to use a different variable. I'm also using a lowercase n there in my work, so I just use k for my summation. And so then here's just the code that actually shows the different areas. So you can see as I unclick this, the actual area has disappeared. Whoops. Let's see. And as I turn it on, it reappears. And so then this here has the code for how I have my left versus right endpoint set up. Right, you have to be a little careful in mapping from -1 to 1 to the interval I've chosen here, which is from 1 to 4. So that's what this is, really just a nice linear translation to give me this kind of sliding scale line. So yeah, Desmos supports all kinds of fun things like that. And what's really neat is you can take things like this and build them into activities where the students can kind of see this graph, but then you can give them very controlled inputs so that they might just have an input box where they type n for the number of rectangles, and then it displays that. And so you have these different components that kind of communicate nicely together through a simple scripting language. So there's a lot of really neat stuff going on behind the scenes that can be done with Desmos. All right, well, I guess that's enough for one time. Thank you very much. And I hope that this video was helpful.